Do parallel worlds really exist? At this very moment, every choice you make feels singular. A single path, a single outcome, a single reality. But modern physics suggests something unsettling, that this reality may not be the only one, that countless others could exist, beyond observation, beyond contact. Not as science fiction, but as serious scientific theory. Do parallel worlds really exist? And if so, what does that mean for reality itself? 1. The question humanity could not avoid. For most of human history, reality was assumed to be singular. One universe, one timeline, one unfolding sequence of events. But as physics advanced, the simplicity of that assumption began to fracture. At the smallest scales of existence, reality behaved in ways that defied common sense. Particles existed in multiple states. Outcomes were governed by probability. And suddenly, scientists were forced to ask a radical question. What if reality itself branches? 2. Quantum mechanics and the problem of measurement. In quantum mechanics, particles do not have definite properties until they are measured. Before observation, a particle can exist in multiple positions. A system can hold several outcomes at once. This is known as superposition. The question that followed was profound. What happens to the other possibilities when a measurement is made? One interpretation suggests they vanish. Another suggests they do not. 3. The many worlds interpretation. In 1957, physicist Hugh Everett proposed what is now called the many worlds interpretation. According to this idea, every quantum event causes reality to split. All possible outcomes occur. Each outcome exists in its own branch of the universe. Nothing collapses. Nothing disappears. Reality multiplies. This interpretation removes randomness, but introduces an infinite number of parallel worlds. 4. Why many worlds is taken seriously. Many worlds is not fringe science. It is mathematically consistent with quantum mechanics and avoids the need for mysterious wave function collapse. Some physicists prefer it because it treats the equations of quantum theory as literally true. However, it comes at a conceptual cost, an unimaginable number of unseen universes. 5. The multiverse beyond quantum physics. Parallel worlds are not limited to quantum theory. Cosmology introduces its own versions of multiple realities. One proposal suggests that during cosmic inflation, different regions of space stopped inflating at different times, creating bubble universes. Each bubble could have different physical constants, different laws of physics, different outcomes for matter and energy. Our universe may be just one bubble among many. 6. The mathematical universe hypothesis. Some physicists go even further. They propose that every mathematically consistent structure exists physically. In this view, reality is mathematics. All possible universes exist by necessity. Existence requires no special conditions. This is not widely accepted, but it is taken seriously enough to be debated in peer-reviewed science. 7. What we can and cannot test. Here is the critical limitation. Parallel worlds, by definition, do not interact with ours in observable ways. This makes them difficult, and perhaps impossible, to test directly. Science relies on evidence. Parallel universes remain theoretical. They explain observations, but they do not yet make unique, testable predictions. 8. Skepticism within science. Not all physicists accept these ideas. Some argue that unobservable universes violate scientific simplicity. Interpretations should not multiply entities unnecessarily. Mathematics alone does not imply physical reality. Others accept the math but reject the metaphysical conclusions. This debate remains unresolved. 9. What would it mean if they exist? If parallel worlds are real, the implications are profound. Every decision you make could exist in countless variations. Identity becomes less absolute. Uniqueness becomes contextual, but meaning does not disappear. Your experiences remain real within this branch of reality. 10. Where science stands today. What science agrees on. Quantum mechanics is accurate. Cosmology suggests vast, unseen structures. Mathematics allows multiple interpretations. What remains unknown? Whether parallel worlds are physically real, whether they can ever be tested, whether the universe is singular or plural. The question is open. Parallel worlds may exist, or they may not. What matters is what their possibility reveals. That reality is deeper than intuition. that certainty is limited, and that the universe continues to surprise even those who study it most closely. If this exploration expanded your perspective, consider liking the video and subscribing to Interesting MindHub. Because the most important questions are not always the ones with immediate answers.